Welcome to the algebra class. We are covering sections 1.6 and 1.7. We're going to be working with word problems, reading them in English, and then translating them into math equations. So we need to be able to read the problem carefully and choose a variable and represent the unknown. And in most cases, you're going to have two unknowns. So we're going to build upon the variable that we first choose. Reread the problem, write the equation, solve the equation, and find the unknowns asked for, and then check your results with the words of your problem and give your answer. The basic math review on your vocab check for tomorrow will be adding and subtracting fractions with different denominators. So in the first example, the least common denominator for 5 and 7 would be 35, smallest number that 5 and 7 go into. So just mentally list the multiples of the larger denominator until you find one that both 5 and 7 go into. 5 goes into 35, 7 times 3 is 21. 7 goes into 35, 5 times 2 is 10. So adding the numerators, we get 31. So there's a total of 31 35ths that goes back over the denominator. Subtracting fractions with different denominators, we have to find the least common denominator. If I take the multiples of 15, the first one that they both go into is 45. 9 goes into 45 5 times. 5 times 4 is 20. 15 goes into 45, 3 times 3 is 9. So subtracting your numerators, 20 minus 9 is 11 over 45. You need your paper for the evens for the video. Okay, make sure your paper's headed math room number, full name, full date. You skip a line. The title is on page 24. We're going to do problems 1 to 18. And on page 28, problems 1 to 10. Be sure and keep your work to the left side of the fold. Don't go past the fold so you have room to do the odds in class. Problem number 2. I have typed out all the problems. You don't have to write that down. You are to write what's in blue. Number 2 says, 1, Lynn has twice as much money as Joe, and 2, together they have $63. How much money does each have? Now, we're not going to solve the problems. We're going to represent our unknowns and then write an equation that we could use to solve the problem. There are two unknowns, Lynn and Joe, and to decide which one is going to be represented by a variable first, always look at what the last thing is mentioned and we can build upon it. So if I let J equals Joe's amount of money, then I can take 2 times J, Lynn has twice as much, and represent Lynn. So 2J equals Lynn's amount. The second sentence gives me my equation. Together they have $63. So if I take Joe's amount, J, and add it to Lynn's amount, I get my equation. J plus 2J equals 63. Problem number 4. First statement says State College has 620 students. Second statement, there are 20 more women than men. Men is the last thing mentioned, so I'm going to let the variable represent that. So M equals the number of men, and it said there were 20 more women, so M plus 20 equals the number of women. And I know together there are 620 students at State College, so if I take the number of men, M, add it to the number of women, M plus 20, it should equal 620. I put parentheses around M plus 20 just to clarify it was the number of women. You don't have to have the parentheses there. Problem number 6. First statement, Brenda drove 3 times as far as Jan. Second statement, Brenda drove 24 miles more than Jan. How far did Jan travel or drive? Either one of these could be used to set up the unknowns. I'm just going to take the first one. In the first sentence, Jan was the last thing mentioned, so I'm going to let J equals Jan's distance that she drove. Brenda drove 3 times as far, so 3J equals Brenda's. Now I'm going to use the second sentence to come up with the equation. Brenda, which is represented by 3J, drove is the verb, so that's equal. 24 miles more than Jan, J plus 24. Problem number 8 says the Ravens won twice as many games as they lost. Second statement, they played 96 games. How many games did they win? First sentence will help me set up my unknowns. The last thing mentioned was lost. So if I let L equal the number of games lost by the Ravens, they won twice as many as they lost, so 2L. 2 times L equals the number of games won. They played a total of 96 games, so the number of games lost, L, plus the number of games won, 2L, has to equal 96. Problem number 10. Skip had 8 fewer job interviews than Woody. Together they had 20 interviews. How many intervals did each one have? Woody was the last thing mentioned in the first sentence, so I'll use W for Woody equals Woody's number of interviews, and I'll build upon that W to represent Skip. It said Skip had 8 fewer job interviews. So Skip would be W minus 8. Together they had 20 interviews. So Woody, W, plus Skip's amount of interviews, W minus 8, has to equal 20. Number 12, first statement says the number of items on 2 grocery lists differs by 7. The total number of items is 33. How many items are on the list? Well, this doesn't give me anything to build about. I just know that there's 2 totals of items on 2 different grocery lists. So I could start out, let's say, let X equal the smaller amount. That's the generally accepted way to start if you don't have anything listed last. So if X equals a smaller amount and they differ by 7, then X plus 7 would have to equal a larger amount. You could do it the other way over here. So together, the smaller amount X plus the larger amount X plus 7 has to equal 33. Choose one of these to use. Both are correct. Problem number 14, a ribbon 9 feet long is cut into 2 pieces. On these problems here, it's a good idea to draw pictures of what's happening or the geometric shape. So a ribbon is a rectangle and it's cut into 2 pieces. It's 9 feet long. One piece is a foot longer than the other, so there's a small piece and a larger piece. So I'm going to let X equal the smaller piece, and the other piece is 1 foot longer, or X plus 1. Together they have to equal 9 feet, so the smaller piece X plus the larger piece X plus 1 equals 9. Number 16, the length of a rectangle is 1 unit more than its width. If the area is 30 square units, find the dimensions of the rectangle. We're building on the width. It's the last thing mentioned, so W equals the width. You need to draw the picture and label this because this is representing your unknowns. The length is 1 unit more, so W plus 1 represents the length. The formula for finding area is length times width. So A is replaced with 30, that's our area, equals the length was W plus 1, so we put it in parentheses, and we multiply it by W, the width. Problem number 18, a triangle has 2 equal sides and a third side that's 15 centimeters long. If the perimeter is 50 centimeters, how long is each of the 2 equal sides? So we draw the rectangle, represent the unknowns, X and X, because they're both equal sides, and then 15, and we have the perimeter equals 50. Perimeter is the sum of the 3 sides, so 50, the perimeter equals X plus 15. And the last part is on page 28. On 28, they're doing basically the same things, but then they give us an answer, 3 answers to plug in and check and see if they work. So that's an extra step there. Number 2, the gym is 21 years newer than the auditorium. The gym is also 1/4 as old as the auditorium. I'm going to use the first sentence to get my unknowns. And remember, you have to write down the unknowns to represent each unknown. So X equals the age of the auditorium. The gym is 21 years newer, or less old. So X minus 21 equals the age of the gym. Second sentence I can use for my equation. The gym, which is X minus 21, equals 1/4 the age of the auditorium, which is X. Now I have to plug in my numbers and see if they work, and I want to see the work for this. So if I put in 26, I get 26 minus 21, which is 5, and that does not equal 1/4 of 26, which is 6.25, so 26 is not my answer. If I plug in 27, I get 27 minus 1, which is 3, and 1/4 of 27 is 6.75, so that doesn't work. So last one, plug it in, make sure it works. 28 minus 21 is 7. 1/4 of 28, 4 goes in the 28, 7. So my auditorium age, that's X, is 28. And the gym is 21 years younger, so 28 minus 21 equals 7. Problem number 4. One number is 4 times another number. The larger number is also 87 more than the smaller number. I'm going to use the first sentence. It says one number is 4 times another number. This other number is the smaller number, so X equals the smaller number. The other number is 4 times that number, so 4X equals the larger number. Second sentence gives me my equation. The larger number, 4X, equals 87 more, 87 plus the smaller number X. They give us 3 possible solutions, 29, 30, and 33. We're going to plug them in and see which one works. If I put 29 in, I get 4 times 29, which is 116, and 87 plus 29, after plugging in 29 for that X, gets 116. So the 29 is the solution. The smaller number is 29. The larger is 4 times 29, which is 116. Problem number 6. A clown weighs 60 pounds more than a trapeze artist. The trapeze artist weighs 2/3 as much as the clown. How much does each weigh? We're building on the trapeze artist in the first sentence, so I'm going to let X equal the weight of the trapeze artist. The clown weighs 60 pounds more, so X plus 60 equals the weight of the clown. Second sentence gives me my equation. The trapeze artist, which is X, weighs as your verb, equals 2/3, there's your 2/3, as much as the clown. And the clown was X plus 60, and I have to put it in parentheses because it's 2/3 of the entire weight of the clown, which is represented by X plus 60. Now we're going to check out the numbers and see which ones work. Putting in for both X's 110. 110 equals 2/3 of 110 plus 60. That's 2/3 of 170, which if I multiply that out and divide by 3, I get 113 1/3. That doesn't work. Plug in 120. I get 120 equals 2/3 of 120 plus 60. So 120, 120 plus 60 is 180. Cancel the 3 with the 160. I get 60. And 2 times 60 is 120. So that does work. So my weight of the trapeze artist is 120. And the clown is 60 pounds more. So the clown weighs 180. Everything in blue has to be on your paper. Problem number 8. The 9th grade class has 17 more girls than boys. There's a total of 431 students. How many boys are there? How many girls? In the first sentence, the last thing mentioned is boys, so I'm going to let X equal the number of boys. The girls, there are 17 more girls, so X plus 17 equals the number of girls. There's a total of 431 students, so I'm going to say X, the number of boys, plus X plus 17, the number of girls, equals 431. And we're going to check the three possibilities. If I have 191, I have 191 plus 191 plus 17. That comes out 399. That doesn't work. If I put in 202, 202 plus 202 plus 17, I get 202 plus 219, which makes 421. And that doesn't equal 431. So if I put 207 in, I get 207 plus 207 plus 17. That's 207 plus 224. That does make 431. So there is a total of 207 boys, and add 17, there's 224 girls. Problem number 10 says Western State College is 18 years older than Southern State. Western is also 2.5 times as old as Southern. How old is each? Using the first sentence to get our unknowns represented, Southern State was the last thing mentioned, so X equals Southern State's age. Western State College is 18 years older, so X plus 18 equals Western's age. Then the second sentence gives me my equation. Western, which is represented by X plus 18, is equals 2.5 times, I change that to a fraction, 5 halves, Southern, X. So now I'm going to test out the possible answer starting with 12. 12 plus 18 makes 30. Putting in 12 for X, the 2 cancels with the 12, making 6, and I get 30. So that's the answer. 12 is Southern's age, and 12 plus 18 is Western's age. And I think I made a mistake on the number of problems. So go back at the very beginning. It's 1 to 10. I think I had the title wrong. It should just be 1 to 10. So we're okay. And that's the end of the problems. Good luck on your odds.